do for the calculator, and I think I'll go over those after because it won't really make sense to you right now. And then storage keys. All right, so I'm going to start here. We're going to be in chapter 4 talking about the time value of money. And we begin with a simple model known as the two-period model. Now, this seems very basic. You might have seen it before, but I want you to pay close attention because it can mess you up. So we begin here. We're here. So when I speak about now a decision is being made, I'm usually going to position myself here. And every position on the timeline has two perspectives. It's the end of something and it's the beginning of something else, right? So time now, 0, is both the end of period 0, but the beginning of period 1, right? So that's very important, and you'll see why, right? So we're going to see this as period 1 is starting, the beginning of period 1, and then the end of period 1 is marked by a 1 on the timeline. So 1 marks the end of period 1 and the beginning of period 2 to the end of period 2, the beginning of period 3. So that's it. That's my timeline. Finance, the idea of finance arises because people are different. Some people want money available or liquid. They want money available to them now or today, this moment. And other people are willing to forgo money today for a price. Does anybody know what that price is called? Nobody? Take a guess. Okay, let's go on. Do you remember that? Yes? All right, so let's do this problem and maybe it'll come to you.
Teacher,
Yes?
can you hear me?
It's very loud. Go ahead.
Do you understand Spanish?
Yes, you can speak Spanish.
Oh, pues profesora, sería lo interese.
Exacto. Very good. Thank you. So the price of foregoing consumption today is the interest rate. So here's an example, right? So clearly different people will require different interest rates to forgo consumption, right? Some people Some people will be satisfied with a low interest rate. Some people would require a higher interest rate. Right? They're not ready to give up the possibility of consumption. And in event that person who's ready to give up their consumption can either lend or invest. Now, usually in economics, we differentiate between lending and investing, but they achieve the same purpose, right? That a person is ready to forego their consumption to give it to some indirectly or directly to someone else for their purposes, but they want to be paid for that, and that's the interest rate. That's their return. There's different names for the interest rate, and you'll learn that in this course. There are different names for the interest rate, but essentially it's all an interest rate. So here's an example. The interest rate is 8%. So as I mentioned, there's many interest rates. I'm just picking this one for this problem, okay, for this problem. It was identified that the 8% is the prevailing interest rate that applies to this problem. So in a world with an 8% interest rate available, what is $1,000 invested today worth in 2 years? How much is what we call simple interest and how much is compound interest? Now, I know you've seen problems like this before. You must have seen problems like this either in high school or in another business class, or you just happen to know about interest rates because you have a bank account or you have investments. So I want you to answer 3 problems for me. I want you to put the answers in the chat and then we're going to talk about it, okay? But feel free to speak or communicate in Spanish. I understand Spanish. I just don't speak Spanish very well. Let's say I speak English better. Let's just say that. Okay, so I'm watching the chat now on my phone because I cannot see it on my computer screen. Okay, what's the question, Sebastian? Oh, about what my question? There's an interest rate. What is $1,000 invested today worth in 2 years? Let's see if you can do that. So give me an idea. Dime. Someone has to talk.
I will say or think that in the first year I will make $80 on interest, so I will have $180. That's the
Okay.
first year.
Okay. And then what
But
happens? So how did you calculate that?
the principal amount, the $1,000, and multiplied by the interest rate and the 12 months. So
Is this
the
what
8%
you're
of
thinking?
1,000 is 80.
Right. Okay. So this is what you did, right?
No. Well,
No?
I didn't sum the twice the 1,000. I did the second one.
Yes.
Yeah, exactly. Yeah.
So that's the interest. So how much would $1,000 become? It becomes 1,000 plus 80. Don't forget it becomes both, right? Because you still have the 1,000.
Yeah.
1,080. Yeah, very good. So you have the answer. Okay. And then what about 2 years? That's the first year. Now what happens?
Se le suman 80 más.
So another 80?
No, I think now we have to calculate the full amount of $1,080,
Mm-hmm.
or it's just the 1,000.
Okay, so we have to, all right, so let's do something first. Let's say that I'm going to convert this to something like this. If everybody's okay with it, I'm going to write, can I write this?
Yeah.
Like if I see this as a 1 here, so it's 1,000 and then 8% of 1,000, so it's like that. And let me write it again. Like let me write it like this. Is that okay? Now I'm doing that because I want to show you something after. So this one is 1,000 plus 80 because you get the principal back plus 8% of 1,000 as interest. So this is what it's worth after year 1. Another way to write it is like this, where this number is the principal plus the interest. That's how we like to write it. So I'm going to make it smaller to move it out of the way. And I can also write this, everybody's agree, I can write this as 1,000, 1.08. Is everybody okay with this, what I did? So everything I wrote here is the same. 1,000 is 1.08. It's also 1.08 times 1,000, it's the same. So try this, make this calculation on your calculator, just using the regular calculator function, where you understand there's a multiplication here. In the next year, we're going to repeat, we're going to compound this amount because this amount is invested and it remains invested. We don't withdraw any funds, we leave it invested. So we have another $1.08 times. Let me make this clearer. Just one moment. Okay, so what I'm saying is 1,000 for year 1, but then we're going to do it again, year 2. Is everybody okay with that?
Yes.
¿Tiene sentido? Well, I just repeat, right? It's the same thing. So I can write this So we're going to call this a name. We're going to call this, this amount is, this is the factor of accumulation factor, accumulation. Right, so the factor 1 plus 8%. And this is 1080. Now do another 1.08 multiplied by 1.0. What do you get? I can write it like this. Again, now it's the accumulation factor, but now I raise to power 2 because there's 2 periods. Oh, I'm going to look at the chat. Okay, so put
teacher,
the answer in. Yes.
1,166 with 40 cents.
Very good. Like this? Does everybody get that answer?
Yes.
Yes. Good. Very good. All right. Now, so what did we find? We just answered A. So the answer to A is one. Oops. Sorry. Put it in blue. Okay, so that is the amount. $1,000 grows to $1,166.40. How much of that is simple interest and how much is compound interest? So this is what we're learning now, okay? We are compounding, and we see the compounding factor here, 2 years, 2 periods of accumulation. Okay, so maybe I have to put it like this because this is the, not the 1,000. The 1,000 is not the accumulation factor. The 1,000 is the principal. So let me put names on these things. So while I'm doing this cleaning here, you are going to tell me what is simple interest and what is compound interest. What is the difference and what are their values?
I think compound interest is on periods of time, like trimesters, semesters.
Okay, so the idea here is we have 2 amounts. We have the 1,000, and now after the first year we have 80. Interest in the second year is going to make 1,000 grow bigger, but it also makes 80 grow bigger. So simple interest is just the interest earned on each 1,000, but compound interest is the interest on the interest. How much 80 continues to grow. All right, so what would the amounts be? What would the dollar amounts be? Take a guess. So the total should be well, we made $166.40 in interest. So which part is simple and which one is compound? Do you know?
80 es simple. Y 86,40 sería compound.
Okay, put it in the chat. Can you put it in the chat?
Voy.
Well, the simple should be over the whole time, over the 2 years. It's over 2 years. Okay, so he said 86. So, okay, so yeah, you have to partition this into simple and compound. Okay, so it's not 80. It's more than 80, but you got the right idea. So let me put the definition here. So simple interest is like not using the fact that we have an exponent here. It's just treating it like 2 years of $80 and forgetting to consider that the 80 has also accumulated interest. So simple interest is just 80 times 2, or more in general, it would be 0.08 times 1,000, or maybe I'll do 1,000. It's like 1,000 times 0.08 times 2. That's simple interest. So how much is it? $160. So then what remains? Compound interest is what remains. So the total interest, I'll make a note here. The total interest is 1. The total interest is 11640. The simple interest is, in general, for a formula, you would write, well, no, I'll make the formula after. So it's the principal amount times the rate times the number of years of interest. So it's just 160. But because we reinvest and we earn interest on the interest, is more. So the way you can calculate compound interest is taking the total interest minus simple interest. How much is it?
Negative 43.6.
But wait, because the total interest isn't 166
So
points.
I wrote the wrong number. 166. This is a 6. Sorry. There. So 166.40 minus 160. How much is it?
6.40.
Very good. Okay, so in this class, there are going to be a lot of formula, and I'm going to do my best to put them in an organized way in your notes. You should either you're going to print the notes or just put the formulas on one sheet. That's up to you, but I will present you, these notes will be in the platform with Moodle, and then I'll also have a sheet of formula that I'll share with you, okay? So you can work with that. And these formulas will include how you how you see the pattern. It's just going to be the pattern to calculating interest, to calculating the value, what's called the future value, how to calculate simple interest and how to calculate compound interest, and a lot of other formulas. All right, do you understand then? So simple interest is just looking at the original principal investment as though there's no compounding effect. But in fact, there's an extra $6.40 because of the $80 also having interest compound. So how do you see that number? What's 8 times 8? This comes from that's what I mean, the interest on the interest. You see? So over 2 years, it's not a lot of money, $6.40. But how do people often pay interest? Do they wait a year? How often do you pay a mortgage?
Todos los meses.
Todos los meses. So it's not just 2 periods, it's going to be 12. And it's not just going to be 1 year, it's going to be many. So you can see interest on interest can really accumulate. Okay, so let's see. Let's from here, I want to show you a formula, what's called the future value formula. The future value formula, and then show you how to use your finance calculator to get this value, okay? So here are the things that we did in our calculations. You're going to see I'm going to use this, and the notation here was sub 1 and then sub 2. So let's see, here is my formula. Future value at time t equals the present value or the principal value now, and this is the accumulation factor to how many periods. So this number here, the exponent, is the same as this value here. Okay, so let's go over what these symbols are. Hold on, let me go here. Okay, so this is the formula I just showed you. The formula is programmed into your calculator on the 3rd row. On your calculator, they use N for the duration of the investment, where T is on your formula, but they use N on the calculator. I by Y is the interest rate. It's like interest per year, something like that. PV, it stands for the present value or principal value. Principal amount invested. I'll say value just because it. PMT, we have no PMT in this problem. There is no payment. There is nothing else happening, but that is on the calculator, and I'll show you in a minute. FV stands for future value, and we have to ensure that we set up this so that each payment is once per period. So we got to set this up. All right, so let me show you the calculator, and then we can talk about this. All right, so the third row is here. You see N, I, PV, PMT, FV. Does everybody see it?
Yes.
All right, so this is maybe the first time you use the finance keys on your calculator, so we need to set something up to make sure the calculator works properly as we intend. You see here on top of I by Y, there's P by Y in blue. We need to make sure that that in the calculator is programmed for one payment per year or payment per period. So to activate, you have to hit second function, P by Y, and make sure there's a 1. If there's not a 1 there, you have to put a 1 and then enter. Did anybody not have a 1 there? Everyone's good? So now when I hit second P by Y, it should show 1. Everyone should have a 1. All right, so no complaints. Let's enter the information from left to right. We begin with the years. We put the number first. So 2 years of investment. So press the number first and then N. So 2, N. We don't have to press enter, I don't think. No. You just have to press 2N. Next, the interest. How should I enter the interest? As 8 or 0.08? In the calculator, you enter 8, okay? This is tricky. It needs to be in whole percentage. 8. The principal value, the principal amount was 1,000. This is a finance calculator. You need to indicate, for the formulas, you need to indicate if this is a cash outflow or a cash inflow. It's something that the calculator needs to add to solve certain problems. In this story, I'm investing $1,000. It's a cash outflow, so I need to make this a negative. Everybody's got it? And then enter PV. Negative with the key here. This key will make it negative. This problem does not work with any kind of payment. It's just an investment, and we'll talk about that PMT key later. So just enter 0 into payment, and we are done. What we're going to ask the calculator to do is compute. So in the upper left corner, hit compute, FV, and you see the answer. Notice it's a positive because if you invest negative 1,000, then you get back a positive 1,166.40. Now you may have learned how to do this in Excel, or you may want to do this in Excel, but I teach with the financial calculator. I'm not going to work with Excel. But if you can do it on the financial calculator, you certainly can do it on Excel. Any questions? Everybody gets the answer? Everyone feels satisfaction?
Yes, I got the answer.
Very good. Good. Oh, we have a big group right now. Oh, no, wait. Not everybody's here. Those are just the invited people. I see 16 people, so 15 students. All right, half the class. All right, so any questions? Everybody's got it. You need to use the finance calculator for this class. All right, so don't delay learning how to use it. All right. So what we've used in the calculator is a worksheet. It's a part of the calculator that has a worksheet for financial, for the time value of money calculations. There's other parts of the calculator, and we will get to those. What we want to do is make sure when we do a new problem that we clear the calculator. And maybe I'll show you right now. So that was part of the instructions at the beginning. So let's say I want to clear the work from the time value of money key. Does anybody see where I can do that? How I can do that? Just looking at the calculator, or do you know? If you guys do it, if the students do it, you're more likely to remember than if I tell you. How do I clear the keys, the memory? Any guesses? There's a word that says reset, and you don't want to use that. You don't want to use that because that resets the whole calculator back to
In
manufacturer.
the left bottom.
Left bottom. Let's try that one. So it's blue, right? It says clear work.
Yeah.
Like I could just clear this, but this is still here. Oops, wait. Oh, it cleared. What did I do? I shouldn't, oh, because I hit reset? Oh, I don't know. Let's do this again. I'm gonna put the numbers back. But if you hit second, clear work, it should clear once you're in an application. So if I'm here, I'm gonna repeat what I did. 8, 1,000 negative, nothing here, and compute. Okay, so those are the numbers inside. So there's two things I can do, I believe. If I just hit clear, I don't think that's gonna work because it's still there, you see? It's still there. The values are still there, although it's messing up. Compute. Oops, now what did I do? Anyway, there's stuff in there and I want to clear it. So if I'm in the third row, I can hit second clear work. It doesn't work, does it? No, so that doesn't work. I have to hit second clear TVM. You see on the upper right, above FV, that should work. And now if I hit compute, if I clear the screen, so this is just to clear the screen, this one. If I hit compute FV, there's nothing there. But I cleared it some other way just now, and I don't know what happened, but it cleared it somehow. So to be sure that it's clear, use second TVM, clear TVM, because that will empty all the cells. All right, so that's for TVM, time value of money. All right, so what we've done is I've explained this formula. Now note, we just used 2 years, but If you have more years, it's the same formula. You just change, if it's 5 years, you make this 5. Make this 5 as well, the future value. All right, so you must have learned this at some point. Now you're going to be experts. I'm going to make sure you're an expert in this. So this is what we did. We entered the values. These are my symbols for what we just did. Okay, so you can rehearse or practice. And we compute FV, and this is what we get. And when we see this number, we interpret it as a dollar amount. So we have accumulated to find the future value of $1,000. Let's continue. This is just a note of how I calculated a simple. So there's another formula here that you can highlight. And that is that we can calculate simple interest as the present value times the interest is a decimal times the number of periods. That's a simple interest. And then we computed the compound interest as total interest minus simple interest. But we also found it as, I said it was 80 times 0.08. Let's see if we can put that in a formula. So it would be PV0 times I, the interest, to the T. Because well, let me do it in a step. Because this is 80, right? And then we just did times another interest. So the compound interest turned out to be 0 times IT. I'm going to get rid of that X. So this puts together the effect. For simple interest, we just multiply. But for compound interest, we have to use the exponent. It's an effect of the compounding effect. Okay. What about this question? What is the value? So again, the prevailing interest rate is 8%. So this is what I'm prepared, or you're prepared, to trade off money today for. But the question is different. What is the value today of $1,000 to be received in 2 years? In other words, with 8%, what would you, as an interest rate or the trade-off, how much would you be willing to give up today to get $1,000 in 2 years? How will you figure that out? What would you pay today to receive 1,000 in 2 years? So you can think of it as an investment. You can think of it as a loan. And it's only going to be worth 1,000 to you if you spend how much? Or you exchange how much? Coral says 920. Sebastian says 8,000. That's a lot. Are you sure? So I'm think about it like I'm being promised $1,000 in 2 years if I give up a certain amount. What is the most you would give up to get $1,000 in 2 years? Uh-huh. Ricardo. And how did you do that, Ricardo?
Dividir los $1,000 entre la tasa de interés elevado al cuadrado.
Okay, and okay, so what Ricardo did was he took this relationship here, the time value of money expression, but seeing that he has this amount, he has this amount, and he has this amount. This is the one he doesn't have. So this is algebra. Essentially, it's algebra to solve. It's PV0 equals future value divided by an accumulation factor. We say that one, well, let's make the calculation first. Let's make the calculation first. So what we're doing is we say it's called discounting. And 1 over 1 plus IT is called the discount factor. Okay, so the amount becomes PV0 is 1,000 divided by 1.08 to the power of 2. Now let's do this on our calculator analytically. Let's punch it into the regular calculator and then we'll do it on the finance calculator. So let's make the calculation of, so if I take 1,000 divide, now I can do this easily, 1.08 and square it, and there's my answer. You can do it like that, or you can use the brackets. Again, 1,000 divided by 1.08 square, and then equals $857.34. I have to round it because transactions are made in dollars and cents. So I round to 857.34. $857.34. Any questions about my, I can repeat on the calculator if you like. It's very messy. Let me do that again. So what does it say? If the interest rate that pertains to you is 8%, this is the one you identify with. This is what you're willing to trade off consumption today. You're willing to give up $857.34 to get 1,000 later. You're willing to give up less, but this is the most you'll be willing to give up, okay? This is the most. If somebody offers you $1,000 for only 800 and you see 8% as your rate, what should you do? You should take the deal because it's a good deal. So this is you can say it's the most you're willing to pay, or it's called the fair price. If they offer it for less, if you're being offered $1,000 to invest less, then that's very attractive. So let's do this in the finance calculator, and then we will break for today. All right, we'll meet you again next week on Wednesday, and I will have put up the notes, and you will read chapter 1, and we can talk a little bit more about chapter 1. So let's look at how we enter this into our calculator. I just have some calculations there. Okay, so I repeat myself many times. Okay, so here are the steps to enter into your calculator. You enter 2, 8. So you have the same numbers. You're just asking the calculator instead to compute PV after you enter 1,000 into FV. Notice, since you receive 1,000, this should enter as a positive. The result, compute PV, will be a negative, which means that you will spend $857.34 out of pocket, cash outflow, to receive 1,000 in 2 years. And what we're doing is called discounting to find the present value. I'll do it. So make sure it's clear. And I begin 2, interest as a percentage. The present value amount is what I'm looking for, so I don't enter anything. I put 0 in payment. There are no payments in this problem. And the future value is 1,000. So I compute. That's my answer. So what you're going to see is we can solve this formula for future value. We can solve using this formula for present value, but then we can also solve for the other variables. And that's why we like the finance calculator, because the other variables are not so easy to solve without it. For instance, what if another variable other than future value or present value is desired? What if I want to know the rate of return or the interest inherent in this investment, or intrinsic interest for this investment? If a security, so a financial security, sells for $900 today and promises $1,000 in 2 years, what is the rate of return on investment? You know, mathematically, you could solve this. You could solve and isolate I using this relationship. But you'll see later that there are even more complex problems where you wouldn't want to have to do that, or it's just too difficult to do it isolating for the interest rate. You'll see that soon enough. So if I solve this analytically, in other words, isolate I, you could do 1,000 divided by 900. And then this cancels here. What happened? I lost connection. You see again? I don't know what happened. And my interest would be solved like that. What I'm going to do is, you can see I'm going to use a lot of mathematics. So I have an aptitude test for mathematics, but I guess we'll find out just solving the problems. If you need any extra help with the mathematics, please let me know. I'm having a call through here. Maybe it's a student calling me. Hold on. All right. So what do you get in this case? Did I lose a connection? Is that what happened here? Oh, you're there, right? You're still there. So when you solve this, you should get 0.05409, let's just say, or 5.409%. So you should be able to solve it analytically isolating I, but it's even easier on the finance calculator. Let's do it on the finance calculator and then we're gonna go. Oh, you have a class. Okay, so we'll pick up, you can try this on your own and we can pick up here on Wednesday. And I'm gonna refer to these as the TVM keys, right? And you'll see, you'll find the answer just as well. So make sure you can do that and we'll meet on Wednesday. You can start reading chapter 1. So good afternoon. Buenas tardes.
Buenas tardes.
Good afternoon.
Good afternoon.
Thank you.